Now that Cura is all set up, both with the Mason with Mason material profiles, we want to just kind of walk through the different settings within Cura and how they affect the printing of the part, and key settings that you might want to look for, and general operation of Cura just in general. The first tab we have is quality, and quality is just the layer height. And there's two settings in here that are primary, the layer height itself, which are how big of layers or chunks, what resolution this part is printed in. The lowest that the Mason can go through with a standard 0.4 nozzle is 0.3 millimeters. So these are for fast functional prints that don't need a lot of detail. The initial layer height is 0.3. That is what the very first layer will be. That's generally useful for making sure that the first layer adheres well and just goes down successfully, because smaller layer heights can tend to not stick to the bed or not gain enough adhesion to last the entire print. In order to add other settings to Cura, basically expand this menu, if there's some feature that you as an expert user need, all you have to do is click on this gear and it will open up more settings that you can then add to Cura. For example, in the quality tab here that we're looking at, you can also change line width or skirt and brim width. Just by checking these boxes, you now add that feature to that menu, and by unchecking it, it disappears. So check it, shows up, and unchecking it, it disappears. But in general, you don't have to dig too deep into this unless you have something very specific that you need to have occur with your part. So that's quality. Going into shell, you have the wall thickness, which is a standard capability. Generally, increasing wall thickness increases the strength of the overall part, as well as increasing infill, but we'll get to that later. But wall thickness is generally set at 1 millimeter, or basically 2 line counts. And then you have the bottom and top thickness, which top and bottom, fairly self-explanatory there. And then again, other settings that you can activate or deactivate in order to create different performances. One that is very commonly needed and used is the Z-seam alignment. This has 4 different areas, and of course, with all of these, you actually have helper text that pops up when you highlight one of these characteristics that kind of explains what it does to the model. But with Z-seam alignment, you can do user specified, whereby you define the start point of each circumference of a layer based on some XYZ coordinate on the bed. And then you've also got shortest for faster prints, random in order to try to hide the Z-seam, and then sharpest corner, which is another method of sort of hiding the Z-seam and keeping it contained. But those are all those settings. The shell is basically for surface finish. And then infill, again, increasing the infill density can increase strength, or the properties of the part itself to more flexible or different kind of part dynamics. Infill density 20 is generally common. Going above 35 is getting very dense and will increase your print time significantly, and going lower can lead to gaps in the top surface. Materials, basically just print settings and print temperatures and retraction settings. So for, in this case, PLA, the temperature is at 220. If you have some material that is not within the general Mason print material profiles, you can look at that material's properties and instructions and adjust these properties accordingly. Generally, with the Mason, a retraction distance of 4.5 is nearly universal for all materials. You may have to tune it a little bit, again, if the flow properties of your material are different. Same goes for the retraction speed. These are generally constants across all materials, but if you have a very specific brand of, say, PETG, then these may need adjusted. The next tab, speed. Speed, how fast do you want this print to be created? Faster speeds create more defects in the surface quality of the part, but you have a faster print time, so that's generally reserved for simple functional parts, whereas slower speeds are for very fine detail. The default speed for the Mason is 35 millimeters per second. This is a standard speed that is a good combination of quality and effective printing time. This model right here, which is about 3 inches tall and 25 grams, is currently estimated at about 1.5 hours. But infill speed, wall speed, by going through all these other settings that again can be accessed through this gear, they can optimize the overall print time. So if you are optimizing a part for production to be exported to the Slant 3D farm and you're trying to minimize cost, that's when these settings would become valuable, because the infill could be printed very quickly, whereas the outer surface may need a much slower speed in order to refine small details like, say, these patterns on this part. So after speed, we have travel. These are, nothing here really ever needs changed. It changes the dynamics of how your nozzle moves from one point to a next when it's not actually printing. So combing mode actually is a feature that allows the nozzle to stay within the part as opposed to crossing over openings, so that if the nozzle was, say, on this side of the hole and for some reason it needed to jump to the other side of the hole, with combing enabled, it would actually move around the hole, so there's no chance of having stringing through the hole. But again, these settings very rarely need to be modified. Cooling itself, whether the fan is turned on and when that fan is turned on. If you're doing anything with overhangs, the fan always needs to be turned on. If you're doing a very simple enclosed part, or in fact even this part, cooling isn't terribly necessary because there's no overhangs or any sort of features that could sag because cooling isn't present. But again, that's very specific to your part, and in general you want cooling turned on as it is right now. Support. We'll do an entire video on support engineering, but again, here you pretty much want to remain with the defaults for the material profile provided for the Mason. It defines how the support should be generated, where it should go, what kind of overhangs require it, and this is really a discipline in and of itself, so we're not going to go very deep into it. But if you're not familiar, support is removable material that is printed up underneath areas that are overhangs. So for example, these small squares that come out of the side of the sample part, support would be built up underneath this cube so that it wouldn't sag when the nozzle tries to print the very first bottom part of it. So supports are that kind of a resource. All right, build plate adhesion, you have rafts, you have brims, and then you have skirts. A skirt is basically a priming trail around the outer edge. A brim is a collar basically put onto the bottom of the part that increases the build plate adhesion surface area. So, and then the raft is something that is built onto the build plate, and then the part is built on top of that raft. Generally, the raft is only used if you're trying to maintain exact dimensions on the bottom of the part. The skirt is used if you have a very simple functional part and you just need some bed adhesion, but generally, if possible, you want to design your part so that none of these are necessary. But again, within the Mason defaults, the brim is the one that is used because it's the most commonly required for any sort of part, and it's a good general purpose thing to add to ensure a successful print. Dual extrusion isn't necessary with the Mason because it's a single extruder machine. Special modes, print sequence all-in-one or spiralized outer contours. Very few people will ever need these modes, and generally are not necessary. If you're working with your Slant 3D engineer, they will be able to help you define how this should be printed in order to scale it up in production. In general, try to print one part per bed, and that's the optimum way to set up a piece for production. Experimental settings. These are settings that are still in beta, but can create some nice features, so we're not really going to talk about those. If you want to explore them, or if you're familiar with Cura, they are good resources for very specific part characteristics. All right, so that is our walkthrough through Cura.